Hi, this is Sir Amboy, and welcome once again to my lecture series in differential equations. In this episode, I will discuss another important type of DE called the Bernoulli differential equation. This is closely related to the first-order linear DE that we studied in the previous episode. The Bernoulli differential equation is a non-linear DE named after Jacob Bernoulli, who analyzed it in the late 1600s. And the logistic differential equation, which is used to model population with some real-life constraints, is a popular example of the Bernoulli differential equation. Now, to solve the equation, we will use a simple substitution method and convert it into a linear equation. Then, the known method of solution for first-order linear DE can be applied to solve the equation. And using back substitution, the original variable can be brought back so that it appears in the solution. Okay? So, to demonstrate how to solve the Bernoulli differential equation, let's get started. If you recall the standard form of the first-order linear DE, which can be expressed as y prime plus p of x times the dependent variable y equals a certain function of the independent variable q of x. So, this is how the folde looks like. No? This is its standard form. A little modification of this first-order linear DE would lead to this Bernoulli differential equation. Lagyan lang natin siya dito ng multiplier na y raised to n, magiging Bernoulli differential equation na siya. O, di ba? Okay, so the Bernoulli equation can be expressed as y prime plus p of xy equals q of x times y raised to n. So this is almost exactly the same as the first-order linear DE, except that the right-hand side, q of x, is multiplied by a certain factor y raised to n. So this form of the DE is called the Bernoulli differential equation. Now, depending on the value of n, we can solve this DE. If n is equal to 0, then y raised to 0 is 1, and this would give us the first-order linear DE, right? Now, if n is equal to 1, then the equation becomes separable. Okay? But what if the equation is not equal to 1 and also it's not equal to 0? Then we can make this equation linear using a simple substitution. And using the method of solution for the first-order linear DE, we can now solve the differential equation. Okay? So how do we do this? First, we need to convert this into a linear DE. Diba? Sabi natin, para ma-solve yan, i-convert natin siya into a linear DE. And how are we going to do that? By using a simple substitution. But before we introduce a new variable, we need to convert this into something that looks like a linear DE. And remember that the Bernoulli equation is nonlinear. So to make this linear, we have to divide both sides of the equation by y raised to n, so that what will be left on the right-hand side is purely a function of the independent variable, which in this case is x, right? So now, dividing both sides of the equation by y raised to n, here we will get y raised to negative n times y prime plus p of x, and then here, if I divide y by y raised to n, I will get y raised to 1 minus n equals q of x. Okay? Now, after this, we will now proceed to the substitution, and we will introduce a new variable. For example, z. Okay? So, if we let z be equal to the new variable, no, that can replace y raised to 1 minus n. Sir, bakit natin papalitan yung y raised to 1 minus n? Kasi po, para maging mukha siyang linear, dapat yung p of x imumultiply natin sa dependent variable. But here, the original dependent variable is nonlinear. And our goal is to make it linear by introducing a new variable kung saan magiging linear siya. That is why we will introduce a new variable z kung saan magiging linear ang differential equation na ito. Okay? So if we let z be equal to y raised to 1 minus n, I will have to also replace dy in terms of dz. If I get the differential of z, dz, 1 minus n multiplied by y raised to 1 minus n minus 1 is just y raised to negative n. And of course, I multiply it by dy. Okay? Now, we will replace y to the 1 minus n with the variable z. However, we also need to replace dy. Okay? But in this equation, dy can be found here in y prime. Because remember that y prime can be written as dy over dx. So, here, I will just rewrite this entire equation, y raised to negative n times dy over dx plus p of x times y raised to 1 minus n equals q of x. So if you notice, we can now replace this y raised to 1 minus n with z. And if you also notice here, we have a term y raised to negative n dy. And also here, we have a term y raised to negative n dy, and they are similar terms. Thus, I can replace y raised to negative n dy with dz over this factor 1 minus n. Okay? And now I will get 1 over 1 minus n times dz over, I just copy dx. And then plus this p of x, I will just copy and replace this y to the 1 minus n with the new variable z is now equal to q of x. Okay, so if you notice that this equation is already linear in the variable z. But in order to transform it into the standard form of the first order linear DE, we need to multiply both sides of the equation by 1 minus n. So now if I multiply both sides of the equation by 1 minus n, I will get dz over dx plus 1 minus n times p of x times the dependent variable z equals the factor 1 minus n times q of x. So we may now notice that this is now a first order linear differential equation in its standard form. Okay? So before, we only have p of x and q of x as the functions of the independent variable. But now, the p of x and q of x are both multiplied by the factor 1 minus n. Okay? So, I will just simply represent this as the new capital letter P. So, I'll just simply represent this as the new capital letter P. And this will be my new capital letter Q. Okay? And now, using the known method of solution for linear differential equations, if you remember the Yespidex, however, this time the dependent variable is no longer y, it's now z. Okay? So we will be using Zespidex, z, e to the integral of, this time it's capital letter P. Dx equals the integral of capital letter Q times e to the integral of capital letter P dx and then dx. And we should note that the capital letter P here is 1 minus n times the original P of x, and capital letter Q is equal to 1 minus n times the original Q of x. Okay? Now, after solving for this expression, you can revert or you can reinsert the original variable y by replacing z with remember, z is replaced by y raised to 1 minus n so that we can see the original variable y in the solution of this differential equation. Okay? So, di ba madali lang? Kinakailangan lang, pag nagsosolve ka ng Bernoulli differential equation, first, ma-identify mo ano baga ang n. What is the value of n? Okay? Because it will appear in the solution as 1 minus n. Okay? Here, the multiplier of p and the multiplier of q. And then after solving for 1 minus n, you just multiply it to the original p and to the original q so that you can have the new capital letters p and q which you will use for solving the linear DE. After solving the linear DE, you reinsert the original variable y by replacing z with y. Remember that we need to replace z by y raised to 1 minus n so we can see the original variable y in the solution of the equation. Okay? So I think this is pretty easy. So for you to better appreciate how to solve a Bernoulli differential equation, let us solve the first example. Madali lang to. Okay, so solve y prime plus y over x equals y squared over x squared. So as you may notice here, we have p of x, which is 1 over x, and q of x is 1 over x squared. And here, the term y squared represents your y raised to n. So therefore, in this problem, n is equal to 2 because of this term, y squared. Okay? Now, what is our next step? The next step is to compute for the new p. Okay, capital letter p, which is 1 minus n. 1 minus 2 is negative 1. So, that's negative 1 times the original p of x, which is 1 over x. And then, for capital letter q. So, capital letter q is 1 minus n, which is also negative 1, times the original q of x, which is 1 over x squared. And then we now proceed to the solution. So at the back of our mind, we have made this equation linear using this substitution. And remember that we introduced a new variable, z, kung saan linear yung differential equation. And solving for that, z e to the integral of p dx, so z p dx equals is squares p dx dx. Okay, so remember here, capital letter P is negative of 1 over x and capital letter Q is negative 1 over x squared. Okay, so first let us solve for the integrating factor e to the integral of negative 1 over x dx. So if we integrate this, we will get e raised to negative of ln x, which is the same as 1 over x, right? And now, I can replace the integrating factor here, yung e to the integral of p dx on both sides, by 1 over x. So, z over x equals the integral of q, which is negative of 1 over x squared times 1 over x and then dx. Okay? So, this is just the negative of the integral of x to the negative 3 dx. Na kapag in-integrate natin, negative of x to the negative 2 over negative 2. And then, of course, plus c. So, negative of negative will give us positive. So, that's 1 over 2x squared plus c. Okay. Now, I'll just copy this. Z over x equals 1 over 2x squared plus c. And now, using back substitution, I can bring back the original variable y because z is equal to y raised to 1 minus n, or y to the negative 1, or simply 1 over y. So I can write this as 1 over xy equals 1 over 2x squared plus c. If you want to solve for y, then I can multiply first both sides of the equation by x. So that 1 over y equals, if I multiply both sides of the equation by x here, x will cancel, giving me 1 over 2x plus cx. I can simplify this by having the common factor 2x. Okay, so I'll just copy 1 plus cx squared. Because it's just an arbitrary constant, no need to multiply it by 2. Now, if I solve for y from this equation, I'll get y equals 2x over 1 plus cx squared. O, diba? Hindi mo na malayan, tapos ka na pala. So, this is now our general solution. Okay? Diba ang dali? So, we're now able to obtain the general solution of this DE, y, explicitly as a function of x. O, diba? Ang dali lang. Para ka lang din nagsosolve ng first order linear DE, yung Yespidex. Kaso nga lamang, yung y gagawin mong z. At sa dulo, yung z papalitan mo ulit at ibabalik mo ang original variable na y using the substitution that, remember, z is equal to y raised to 1 minus n. Okay? So, kapag ka nag-solve ka, huwag mong kakalimutan ha, na yung z hindi siya ang original variable. Kaya kinakailangan, ibalik mo ang original variable na y using this substitution. Okay? So now, let us proceed to the next example. Solve the equation 6y squared dx minus x times 2x cubed plus y dy equals 0. So, kung napansin natin, itong equation na ito ay nasa differential form, di ba? Pero kung isosolve natin ang equation na ito as a Bernoulli differential equation, dapat magkaroon tayo ng derivative. Remember? So, since meron tayong dx at dy, dalawa ang posibleng derivative na makuha natin dyan. It could be dy over dx, kung saan sanay tayo, or it could be the other way around, dx over dy. Sir, paano ko malalaman kung dy over dx or dx over dy ang aking gagamitin? That depends on the coefficient of dx and dy. Para magkaroon ka ng derivative, kinakailangan kasi na mag-divide ka para yung dx at dy walang coefficient. So, kung magdi-divide tayo, ang gusto nating divisor yung simpler term. So, dito ang multiplier ay 6y squared. Dito naman, ang kanyang coefficient ay 2 terms. So, saan tayo makakakuha ng equation na mas madaling isolve? Kapag ang coefficient ay isang term lamang. Kaya ito yung gagawin nating pang-divide para makakuha ka ng derivative. So, if that is the case, then ang makukuha nating derivative is dx over dy. So, therefore, we need to divide this entire equation by 6y squared dy. No? At pag ginawa natin yon, ang makukuha natin is dx over dy minus, ito kopyahin ko na lang, x times 2x cubed plus y. O, so wala na yung dy kasi nga divisor na siya. Ito na siya, divided by 6y squared equals 0. Ayan. So, kung mapansin natin, ang ating dependent variable dito ay x at ang independent variable naman ay y. So, ano ang magiging form ng ating Bernoulli differential equation? Dati kasi meron tayong y prime, di ba? Plus p of xy is equal to q of x, right? So, sulat ko lang ha. Y prime plus p of x, y equals q of x times y raised to n. So, in this case, ang ating dependent variable ay y at ang independent variable ay x. But this time, nabaliktad. Kaya dito, babaliktarin lang natin. Sa halip na y prime, na dy over dx, magiging ano siya? Dx over dy. Ito yon. And then, dapat magkaroon tayo ng plus, hindi na p of x. Dapat magiging p of y na siya times the dependent variable x equals, next, sa kabilang term, hindi q of x, rather, q of y times yung y, gagawin mong x, x raised to n. So, ganito yung format ng Bernoulli differential equation na dapat nating makuha. So, let us write this equation in this form. So, I just copy dx over dy. Then, okay, so here, minus yung sign. Minus, alin yung p of yx? Okay, so this is my y over 6y squared, and this is my x. So that would be my p of y x. Okay, so negative of y over 6y squared is just 1 over 6y. And then I just copy this variable x. And then equals q of y times x raised to n. Okay, q of y times x raised to n. So alin yan? So ito yon. We have here x times 2x cube. So that will be 2x to the fourth. So yun yung x to the n mo ngayon. Tapos yung q of y, ito pa rin siya. 6 over y squared. So magkakaroon tayo ng 2 over 6 over y squared, which is your q of y. Okay? So 2 over 6 is just 1/3. And then y squared. At multiplyan ko siya ngayon ng x times x cube is x raised to 4. Okay? So this is now the form of the Bernoulli differential equation that we obtained from the given differential equation. So here, it is very obvious that n is equal to 4. Okay? So in this problem, n is equal to 4. Therefore, magkakaroon ako ng 1 minus n na equal sa negative 3. Okay? And what will be my new p? Okay, so here, my p of y, not p of x, this time it's p of y, is 1 or negative 1 over 6y. So I just multiply it by negative 3. Negative 3 times negative 1 over 6y is, negative is positive, 3 over 6 is 1/2, so 1 over 2y. Okay, now how about my new q? My new q will be negative 3, that's 1 minus n times the original q of y. The original q of y that we have here is 1 over 3y squared. 1 over 3y squared. Therefore, capital letter q, which we will use to solve for the linear equation, is negative 1 over y squared. O, diba? Okay. So, since meron na tayo ngayong capital letter P at capital letter Q, ang gagawin na natin is yung solution ng linear DE, kung saan linear siya sa variable na z, right? Z times E raised to the integral of P dx, not P dx, rather, it should be P dy, because here, our new independent variable is y, equals the integral of Q times e to the integral of p dy dy. But e raised to the integral of p dy equals e raised to the integral of p is 1 over 2y and then dy. So if I solve for this, I will get e to the 1/2 ln of y, which is the same as y raised to 1/2. Okay, so this is now the integrating factor that we will use and substitute here. Yan. So z times y raised to 1/2 equals the integral of q, which is this, negative 1 over y squared times y to the 1/2 and then dy. So by simplifying this, that's just the negative of the integral of 1/2 minus 2 is y to the negative 3/2. Okay. Now, I'll just copy this and integrate this part. Z, y to the 1/2 equals, if I integrate this, I'll get negative of y to the negative 3/2. Negative 3/2 plus 1 is negative 1/2. Okay, so that's negative 2y to the negative 1/2 plus c. So this is now the solution of the equation that is linear in z. But this is not yet the final answer because we need to reinsert the original dependent variable, which is x, right? Let me just copy paste this in the next slide. Z, y raised to 1/2 equals 2y to the negative 1/2 plus c. Now I can write z, remember, z is equal to x raised to 1 minus n, which is x raised to 1 minus 4. Therefore, that's x raised to negative 3. So this can be written as y raised to 1/2 over x cubed equals, this can be written as 2 over y raised to 1/2 plus c. So if you want to simplify your general solution, it would be better to multiply both sides of the equation by x cubed times y raised to 1 half. And by doing that, we will get, okay, so x cubed here will cancel and y to the 1 half times y to the 1 half is just y equals, if I multiply this by this term, y to the 1 half will cancel and this will become 2x cubed, right? And this constant would have a multiplier, x cubed y raised to 1 half. O, di ba? Now, para ma-eliminate natin itong fractional exponent na pangit tingnan, ilipat ko na lang ito sa kabila. Okay? For example, y minus 2x cubed equals c x cubed y raised to 1 half. And finally, to eliminate this exponent, 1 half, I can square both sides. Okay? So, squaring both sides, we will get y minus 2x cubed squared equals, if I square c, that's still a constant. And then x cubed, pag in-square is x to the 6th. And then, kapag in-square natin ang square root, ang makukuha lang natin is yung y. Okay? O, di ba? Okay, hindi natin namalayan, tapos na pala tayo. Okay, so this is now our general solution. O, di ba? General solution. Okay? So once again, let us have a recap kung paano mag-solve ng mga Bernoulli differential equation. Kapag Bernoulli ang differential equation, dapat aalamin mo ano ang value ng n. Okay? Kapag nalaman mo na yung n, imo-modify mo lang yung original na p para maging capital letter p, which is just 1 minus n times the original p. And the original q will be modified by multiplying it by 1 minus n as well. Right? Okay. And then after that, mag-introduce tayo ng new variable, z, kung saan linear na yung differential equation, and use Zespedex. Zespedex equals SQS PEDEX-DEX. Okay. So here, the independent variable is x, and the dependent variable is z. So you should be careful because in some problems, the variables might change. For example, in this problem that we solved, the dependent variable in the original equation is x, and the independent variable is y. So we replace the original dependent variable x with z. And what will be left is the new variable z and the independent variable y. Okay? Kasi baka magbago yung mga variables. Halimbawa, yung sanay tayo sa x, baka mamaya maging t yan, or maging ibang variable. Kaya kailangan i-incorporate mo yan dito sa equation na ito. And then after that, ibalik mo ang original variable, no? Dito, yung z. If my variable is originally y, that's y raised to 1 minus n. But in this example, the dependent variable is x, right? Kaya ang ginawa nating representation is z is equal to x raised to 1 minus n. Because here, the dependent variable is x. Unlike here, in which the dependent variable is y. Okay? Di ba madali lang? Ngayon, so kung marunong na talaga kayong mag-solve ng Bernoulli differential equation at natutunan nyo kung paano siya gawin, you should be able to solve this problem. Ayan. So this is our practice problem for this topic. Solve this differential equation. Okay, so paano siya i-solve? Kinakailangan una, i-express mo muna siya in the form of the Bernoulli DE. Ano nga yung form ng Bernoulli DE? It's y prime plus p of x y equals q of x y raised to n. So here, x is our independent variable and y is the dependent variable. However, there are cases in which they will interchange, no? Yung x ang nagiging dependent at yung y ang magiging independent. Depende kung ano yung derivative na makukuha mo, kung dx over dy or dy over dx. Kagaya nung nangyari dun sa previous nating example, okay? So after solving, you may comment your answers down below, okay? So if you like this video, please subscribe to my YouTube channel and see you again in my next lecture video. Bye!